Now, let's take a breather. It was great fun going into so much detail, but everything seemed too technical, didn't it? Yes, that's right. Remember, numbers without an inherent meaning are just numbers. Anybody can read them, but not everybody can understand them. You must always look for ways to get insight from these numbers. Rephrasing the question in data analytics terms would make it sound like this. How can we extract some meaning from these numeric values? And then you wouldn't give up until you obtained an answer. Here's what I mean. The reason for absence column contains integers only. When you hear reason number 1, are you able to immediately figure out why a person was absent during a certain working day? And are you able when you hear reason 22? No, you aren't. So, you should immediately ask yourself, which are the 28 reasons we have substituted with numbers here? I'll give you the answer. We needn't analyze them one by one, but among the reasons given, you have certain infectious and parasitic diseases, diseases of the nervous system, pregnancy, blood donation, physiotherapy, and many other diseases I had never even heard of. Okay, so how should we treat this information analytically? Similarly to the case of the ID column, the values here do not actually have a numeric meaning. They represent categories that are equally meaningful. In other words, reason 1 stands for a certain reason for absence as much as reason 2 stands for another. The fact that in arithmetic terms 2 is greater than 1 has nothing to do with the numbers in this column. You may know from statistics that these variables are categorical nominal. Nominal because instead of using the numbers from 0 to 28, we could have had names, disease, dentist, pregnancy, etc. However, using numbers is the convention for working with categorical nominal data, and there are two main reasons for this. First, researchers prefer to have clear 1 or 2-digit numbers to designate a category, and then assist themselves with a legend to see what phenomenon each number is referring to. In our example, this translates into reading 1, 2, 3, and so on, and then referring to a legend to connect each number with the corresponding disease, instead of reading long strings such as long infectious and parasitic diseases, neoplasms, diseases of the blood and blood-forming organs, and certain disorders involving the immune mechanism, and so on. The latter would overload this column with letters, and it will be very hard to digest this data analytically. Second, from the point of view of database theory, using less characters, 1 or 2-digit numbers instead of multiple character strings, will shrink the volume of our data set. Thus, less data storage will be required to store our information, and this is typically considered as an optimal solution. Then, for the purposes of making a quantitative analysis, we need to add numeric meaning to our categorical nominal values. Consequently, there are several ways to go about this. One of them is turning these values into dummy variables. In econometrics, statistics, and data analytics in general, or more particularly, in regression analysis, a dummy variable is an explanatory binary variable that equals 1 if a certain categorical effect is present, and that equals 0 if that same effect is absent. Therefore, we want to have a column where the values of 1 will appear in case an individual has been absent because of reason number 1, and 0 if she was absent because of another reason. Here's the moment to tell you that the study we have based our exercise on was constructed in such a way that we can be certain that an individual has been absent from work because of one and only one particular reason. This is really important, and in a minute, we'll prove that the information in our table abides by this rule. Then, we'd like to apply this logic for all 28 different values in this column. Intuitively, the pandas method that will allow us to do this with one command is called getDummies. It must be implemented to the reason for absence column from the DF data frame. For convenience, let's store the output in a variable we'll call reason columns. Let's run this cell and see what we get. A separate data set with 28 columns, bearing the numbers from 0 to 28 as their names. Don't forget number 20 is missing. Great! Now, just as we promised, let's check whether we have rows with missing values. How do we do that? Well, if we sum all values of a row and store it in a new column, which we will call check, and obtain 0, then we have a missing value for the given observation. If we get 1, then we have a single value along the entire row equal to 1, and that is exactly what we expected. Finally, if we see a value of 2 or higher in the check column, then we must have either had the value 1 within the row more than once, or we've had a higher number. As we said, this shouldn't be possible because an individual can be absent from work for a single reason only. To create the check column, we need to indicate its name right after the reason columns, and then assign to it the summation of all values along the horizontal axis by using the sum method. Within parentheses, to designate that we want to sum the values horizontally, we must stick to the convention and set the axis parameter to equal 1. Let's execute this line of code and check the content of the reason columns to see if we've worked correctly. So far, most definitely. At first sight, we see only 1s within the last column from top to bottom, with no exception. Let's check this programmatically to prove what we saw was correct. We can once more apply the sum method, this time to the check column directly. Therefore, we'll be interested in adding values along the vertical axis, which means writing axis equals 0 will deliver the desired outcome. After executing this cell, we got 700, and that was precisely the length of our DF data frame we obtained earlier. Remember? Well, for some people, this check would not be sufficient. They'd say, wait, we just skimmed the values from the check column. We did not really see whether or not there was a 0 and a 2 somewhere in there. How can we know for sure all the 700 values equaled 1 precisely? As a matter of fact, you already do. Apply the unique method to the check column and see how many different values you will retrieve. Only 1. The number 1. Bingo! All this proves that initially, the reason for absence column had been flawless, containing no missing or incorrect values. Okay, the validity of reason columns has been checked, and we are satisfied with its state. At this stage, we can and should remove the check column with the use of the drop method. Done. Perfect.